Hello! In this video we're going to use the bisection method to find the root of the value f of x equals x squared minus e to the minus x. What is a root? A root of a function is the value of x at which the function becomes 0. Graphically, if I have the x-axis here and the f of x on the vertical axis, the root is the value of x at which the function crosses the horizontal axis. So, let's solve this function in the x domain of 0 and 1. We are going to refer to our lower boundary as xl, because the lower, and the upper boundary as xu, for upper. So let's start with a table. It always helps. So for our first iteration, the x lower is given to be 0 and the upper boundary is 1. So the next thing we want to find is the function, the value of the function at these two boundaries. So the function at xl equals, we'll take this xl and substitute it in our function. So we'll have 0 squared minus e to the minus 0, which equals minus 1. And in the same way, the value of the function at x upper will equal 1 squared minus e to the minus 1, which is equal to 0.63212. The first thing we notice is that the sign of these two is opposite. This is very important because then this means that at x equals 0, the function has a negative value, but at x equals 1, the function has a positive value. So it needs to cross the horizontal axis at some point. We don't know where it will cross the axis. It could be in any way. Okay. So the next step now is to go in the middle of this domain. So at 0.5. So I'll write here xr equals x lower and x upper divided by 2. So here we'll have 0 plus 1 over 2 equals 0.5. Now, in the middle of this domain, 0 and 1, which we said is 0.5, I want to check if the function has a positive value or a negative value. So how will I do this? I'll take this xr, we just calculated, and replace it in this function. So we're going to find the f of xr, which will be 0.5 squared minus e to the minus 0.5, which will equal minus 0.356. So this is a negative number. So let's plot it on our chart. Here's 0, 0.51, and at 0.5 the value of the function is negative, minus 3.56. Now we observe that f of xl and f of xr are both on the same side of the f of x axis. They are both negative on this side. Okay, this means that there's no root between those two. Okay, it would have been the same if both were positive. Okay, in this case they are negative. So now we can exclude the 0 to 0.5 domain. Okay, our root will be located between 0.5 and 1. And this is exactly what we're going to use for our next iteration. So for our next iteration, we're going to replace x low for our new x low, the 0.5, and our xl will remain the same, 1. It's easy to fill this table. We have 0.5 here, the function 0.5, we found it over there, so it'll be minus 0.356. Okay, the function of x upper, we know it to be 0.632. And now we want to find the new xr. The new xr will be, as we said before, x low plus x upper over 2, but with these values now. So we'll have 0.5 plus 1 over 2 will give us 0.75. Now the next step is to find the value of the function at this 0.75 location. So like we did before, we'll have 0.75 square minus e to the minus 0.75, and this will equal 0.09. So we see that this has a positive sign. It's located there. Okay, so it has a positive sign, and we want to match it with whichever function of the value has negative. In this case, the f of 0.5 has a negative value. So let's change color, and our new domain will be this one over here. Okay, so our new x low is the 0.5, but our new x upper is the 0.75 from the previous iteration, 0.75. The function at xl, like before, is minus 0.356, and the function at the xu now is 0.09. Again, we observe that these two have opposite sign. Okay, always at every iteration this will have opposite sign, otherwise there'd be no root if they had the same sign, and we repeat the process coming in the middle here. So 0.5 plus 0.75 over 2 equals 0.625, and so on and so on and so on.